Being adept at unit conversions is an essential skill for engineers. This is why we are tested heavily on this skill in our PE exams, FE exams, and almost all engineering class exams. One unit conversion that can be challenging is converting the pressure of vapor into its mass concentration. In today's video, we will break down the solution of a classic example to help you better understand this process. So here we have an indoor air quality inspector measured the vapor pressure of benzene in a building following a renovation and found it to be approximately 0.0001 atm at temperature of 25 degrees Celsius. Estimate the concentration of benzene vapor in the indoor air in units of milligrams per cubic meter. To convert the pressure of gas into its concentration, whether it is the molar concentration or mass concentration, we will need to record the ideal gas law, PV equals nRT. In this simple relationship, P is the pressure of the gas, and V is the volume of the gas, N is the number of moles of this gas, and T is the absolute temperature of the environment, typically in the unit of Kelvin, and R is called the gas constant, which is a physical constant that comes in a variety of units. Let's rearrange the ideal gas law into N divided by V equals to P divided by R and T. If we pay attention to the left side of this equation now, we can see moles per volume, and this is called molar concentration. A typical unit for molar concentration could be mole per cubic meter. This is well known that molar concentration can be used to find mass concentration simply by using the molar concentration multiplied by the molecular weight of this compound. We'll see the unit can be changed from moles per cubic meter into milligrams per cubic meter. Let's record the rearranged ideal gas law, and it is now showing us how to calculate the mass concentration from the pressure of vapor. So C equals P over R and T multiplied by molecular weight. Now let's consider each of the parameters in this equation. Pressure of vapor P equals to 0.0001 atm. T equals to 25 degrees Celsius, that is approximately 298 Kelvin. Molecular weight of benzene is 78.112 grams per mole, and since our target mass concentration is milligrams per cubic meter, let's convert this gram per mole into milligrams per mole. So we have 78,112 milligrams per mole. As we discussed earlier, the gas constant comes in a variety of units, and each unit comes with different values of R. Hence, this is very important here that we choose the most appropriate unit of R. But how? Let's take all the known parameters into the equation. So the pressure of vapor P equals to 0.0001 atm. Temperature T equals 298 Kelvin. Molecular weight of benzene 78,112 milligrams per mole. And let's not forget that our target mass concentration is milligrams per cubic meter. Now, to balance the units on both sides of the equation gives us that our gas constant should expect units of atm cubic meter over Kelvin mole. Now that we have our unit for R, we can find its corresponding unit value. According to this long table I found in Wikipedia, we will use R equals to 8.205 raised to the power of -5. So finally, The last step, which is also the simplest step, is to take all the values of the involved parameters into the simple equation for calculation. We can easily find that mass concentration should be somewhere around 320 milligrams per cubic meter. If you want more videos like this focused on how engineers actually think on exams, please like this video, subscribe to the channel, and comment below which topics you would like me to cover in future videos. I'll see you in the next one.